Hey there, let's solve this LeetCode problem. Koko loves to eat bananas. There are in piles of bananas. The I pile has piles I bananas. The guards have gone and will come back in 8 hours. So we'll have to find K. So K is the eating speed of Koko. Koko will eat K bananas per hour. Each hour she chooses some pile of bananas and eats K bananas from the pile. And it happens that if the pile has K less than K bananas, she eats all of them instead and will not eat any more during this hour. So we need to decide the minimum integer K such that she can eat all the bananas within 8 hours. Let's look at the first example here. We have 3, 6, 7, and 11. These are the piles, and the first pile has 3 and the second pile is 6 bananas and so on. And H is given 8. The guards will come back in 8 hours. So now Koko wants to eat all the bananas within 8 hours. So how we can choose the K the eating speed, or in other words, the number of bananas she will eat within 1 hour. So one guaranteed way is to choose K as 11, because the pile with the most bananas has 11 bananas. So for all of this pile, the best we can do is to eat all the bananas in each of these piles in 1 hour. So this will be 4 hours. And this is achievable when we choose K as the most number of bananas in any pile. This is 11. So we have an upper bound here, 11. And we can at least eat 1 banana. That is the lower bound. Now let's take something in the middle. Like this gives us a hint that we can use binary search, but not yet. Let's just confirm that. We have K something in the middle. Let's just say 1 plus 5, 6, something in the middle here, 6. Now we take 6. This means the Koko will eat 6 bananas per hour. Let's see if it can finish all the bananas within 8 hours. Given this here, 8 hours. Koko will eat the first pile in 1 hour. Koko will eat the second pile in 1 hour. Koko will eat the third pile in 2 hours. He will eat the first 6 of them, and then he will eat the 1 of them in the next hour, the remaining one. This will be 2 hours. And Koko will eat the last pile in 2 hours as well. That adds up to a total of 6 hours. 6 hours, which is less than 8. So she's able to complete finish all the bananas, all the piles. So 6 is possible. Now let me clean this. 3, 6, 7, 11, and H is 8. Now when K is 6, and we have this range 11, and when K is 6, when something in the middle, we can do that. We can achieve eating all the bananas within 8 hours. Now, what if we increase K? What if K is 7? So we'll eat more bananas per hour. So that only makes the answer better. We'll finish faster. So if we can finish all the bananas within 6 by eating 6 bananas per hour, then if we eat more than 6 bananas per hour, then we'll certainly finish faster than 8 hours. So within this 8 hours. So there's no need to research our answer so to the right of 6. We have 6, then 7, 8, and 9, and 10. So 7 will certainly be feasible. It will be possible to finish all the bananas by eating 7 bananas per hour, and 8, so is 9 and 10 as well. So we will look for our answer in the range 1 to 6. Now we choose the same thing. We do the same thing. We choose K as the value in the middle. This, let's say it's 3. Now we'll check if we can finish all the piles by eating 3 bananas. Now it will take 1 hour for first pile, 2 hours, and 3 hours here, and it would take 4 hours. We will eat 3, 3, and 3, and 2. And this adds up to 3, 6, 10 hours, which is more than 8. So we're not able to finish all the piles within 8 hours if we choose k as 3. So 3 is not a possible value. And anything smaller than 3 will not also be possible. This will only increase the number of hours. If we choose 2, this will worsen the answer. So we ignore 3 and smaller values. So our range now is 4 to 6. Now we choose again a value in the middle. Let's say it's 5. Now if we eat 5 bananas per hour, the first pile will take 1, this will take 2, this will take 2, and this would take 3. And this adds up to 8. So 8 is equal to 8, so it's possible. So 5 is also possible. So we again shrink down to 4. We shrink. So we have 4 and 5. Now we check 4. Now 5 is possible. Now we check 4. 4 will be possible as well. Let's check that. If k is 4, the first pile we'll have 1. For second we'll have 2, and we'll have 2 here, and we'll have 3 here, and this will be again 8. So 4 is the minimum k, such that she can eat all the bananas within 8 hours. So we can search our answer. We'll have a range. We restricted our answer to a range. We have a lower bound. We say that she can eat at least 1 banana, or she can eat all the bananas. We can choose k as the number of bananas with the most bananas. Here, like 11, or here would be 30, and here would be 30 again. Let's look at example 3. We have 30, 11, 23, 4, and 20. H is 6. Now we have our range 1, and the largest one is 30. We choose something in the middle, 15. Now let's see if we can finish all the bananas by eating 15 bananas per hour. It will take 2 for the first pile. It will take 1 hour for the second pile, 2 for the third, and 1 here and 2 here. That is 3, 5, and 8 hours. So if we choose k as 15, it will take 8 hours to finish all the piles. So 8 is larger than 6. So choosing 15 is not possible, and any value smaller than 15 will only increase the hours. So we choose. So our range is 16 to 30. Now we choose something in the middle. What is the middle here? Then it would be 23, something like that. Yeah, 23. And now we choose 23. Let me clear. We have 30, 11, 23, 4, and 20. If we choose k as 23, this would take 2 hours, 1 hour, 1 hour, 1 hour, and 1 hour. That is exactly 6 hours. We can finish it in 6 hours. So now our range is 16, 23. Now let's choose something in the middle. This would be 4, 5. Let's just say 19. If we choose 19, this would take 2 hours. Running low. Just plug in 2 hours. This would be 1 hour and 2 hours. This would be 1 hour and 2 hours. That is larger than 6. So 19 is not possible. So we have 20 and 23. We choose something in the middle. Let's say it's 21. And if we choose 21, this would take 2 hours again. The 30, this would take 2 hours again. This would take 1 hour. This would take 2 hours. This would take 1 hour. This would take 1 hour. This is again greater than 6. So 21 is not also possible. Now we have 22 and 23. Now let's check 22. If we choose 22, this would take 2 hours. This would take 1. This would take 2. This would take 1, and again 1. Still larger than 6. So 22 is not possible. Now we only have 23 in our range, so 23 is the answer. So you can see it here. Let's actually see the code. Now I've already written this. Here I found sum. And you might wonder, why do I need sum? I didn't choose the lower bound as 1. This would also work, but I choose it sum over h. So you have to eat at least, if we have like in total 50 bananas and the hour is 10, we should at least eat 5 bananas per hour. So that is, so we can finish 50 bananas in 10 hours. So that is the lower bound, and the upper bound will be the maximum in all the number of bananas in any pile. And we have the lower bound and upper bound. This is a usual binary search setup, and we find the middle value. Can't eat all. This is our check function. Higher end of the range is feasible. So I'll explain what that means. The check function is pretty simple. Given piles, an hour and long k, the number of bananas Koko can eat per hour, we'll find how many hours it would take for Koko to finish all the piles for the given k, and we check if total hours is that we can do it easily here. This is an efficient way to calculate the ceiling without using double. If you use ceiling like I've done it here, you have to cast it to integer. If total hours already exceeds the given hour, we don't need to go to the end of the piles. That's an early exit. We just return false. It's not possible. At the end, we check total hour. If total hours is less than or equal to h, the given hour in the problem statement. If the current answer, the current k, is possible, if it's feasible, let's call it feasible, and then the higher end of it, if we eat like 5 bananas per hour and it's possible, anything more than 5 will also be possible. So that's why we shrink. So we shrink the upper bound. So we have upper bound mid. Otherwise, if it's not possible, so any value smaller than the current k will not also be possible. So we increase the lower bound. So we have lower bound mid plus 1. Let's submit this code. Yep, it's accepted and it's pretty fast. This also suggests some other problems. Maybe I'll cover them as well.